So today, people, we are going to talk about the compressibility factor. Now, before the class, I put a small poster saying that one person is squeezing a ball. I said to you that real gases, just to assume it like that. Somebody is squeezing a ball like this with his hand, and I told you real gases, assume it like that. And ideal gases, people, just a metal ball. You cannot compress it, right? You cannot compress it. That's the first thing I need you to put it into your head, right? From now onwards, real gases are squishy balls and ideal gases are metal balls, right? Let's take it slow today. We have a very small part to do. So today, your understanding should be high, right? So make sure you focus on today's class, right? Nice. Compressibility factor. First one, people, if we consider ideal gases, we can write, PV equals nRT. Agree, right? You agree with this. For real gases, we cannot write PV equals nRT. That one also you know. For real gases, PV is not equal to nRT. For ideal gases, PV equals to nRT. You know this concept. But people, PV is equal to something times nRT. I'll put that something as Z. Something times nRT, right? That Z could be certain value, right? Ah. People, this Z, you call that the compressibility factor. You can subject this Z, right? Z equals PV over nRT. Agree with that also, right? Huh. Now, if we consider 1 mole of gas, N becomes 1. Ah. Yeah, familiar with this equation. What? Z equals PV over RT. Teachers told you that this is compressibility factor, and when you compress the gas, this thing increases, and when volume increases, this thing reduces. Right? So you have drawn curves with this also. Now I'm talking to 2025 students, so you have done this thing at least once in your class. So I want you to forget everything that you have learned in class before. And now, with a fresh memory, walk into today's class and sit and listen, right? So we can write Z is equal to PV over RT. If we keep the temperature constant, we don't change the temperature, we keep the constant. Now, what we do is we reduce the volume. When we reduce the volume, pressure tends to increase, right? Agree? Tell me. When you decrease volume, pressure increases, right? Am I wrong? Yeah. When you reduce the volume, pressure increases. Huh. People, if this is an ideal gas, P is inversely proportional to the volume. Accept? P is inversely proportional to the volume. Ideal gas. Huh. V increases, P reduces. And this one increasing cancels off the pressure reducing. That means what? Z is going to stay a constant. PV equals nRT, right? PV equals nRT for ideal gases. That means people PV over nRT should be 1. For ideal gases, Z is equal to PV over RT equal to 1. Hey, team people, when pressure increase, volume should decrease. For an ideal gas, when pressure increases by 100, volume should reduce by 100. So it cancels off. Logically can be accepted, right? Anyone who cannot accept that, cannot digest that, pressure increases, volume reduces, it cancels off. So the outcome is always 1 for ideal gases. But people, for real gases, it is not the same. Things are getting a little bit different with real gases. When you increase pressure, the volume doesn't reduce like that equally. It goes differently. And that differently, if we graph it, we are getting something called compressibility factor variation. If I draw a graph like this, what is this? Pressure. Sorry, yes, pressure. This is pressure. This is the compressibility factor, which is equal to PV over RT, this value, right? This value, PV over RT. You increase the pressure for an ideal gas, the Z value always stays equal to 1. Except, right? The Z value always stays equal to 1. Huh. But people, for a real gas, this is a little bit different. Sometimes it goes like this. Sometimes it goes like this. Sometimes even it could also go like this. Sometimes like this. Sometimes like this. Sometimes won't even go up to the stops here. This is real gases. All these, this one, this one, this one, this one, this one, this one, and this one. All are real gases. But this guy is for ideal gases. Why is it one always? You can see when you increase pressure, volume reduces accordingly. Volume reduces accordingly, right? So that's why this Z is going to stay equal to 1. Did you get the idea? Z is always 1. Why? Pressure increases, volume decreases, it cancels off. So it always be 1. I won't tell you why these things behave like this. Real gases, I won't tell exactly now why do they behave like that. First understand why ideal gas, this thing stays at 1. Right? Got it, right? Real gases do not obey that law. You can see it goes like this, like this, like this, like this. Different variations. And when temperature changes, this one also changes. Temperature changes for real ideal gas, nothing happens. But for real gases, it changes. Okay. Now, take the root till you. Now take the root. The topic compressibility factor I have given. Right. There you have to derive some equation. You have to write some equations, right? For ideal gas, we can write what? PV equals nRT, right? That. For ideal gas, we can write PV equals nRT, right? That. Quickly. Taggalian. PV equals nRT for ideal gases. People, then we are assuming n is equal to 1. When n is equal to 1, you can write PV equals RT for ideal gas. For ideal gas. Write this one also. Then you have to write for real gas, we can write the same number of moles you are considering. For real gas, we can write Z is equal to PV over RT. Right? For real gas, we can write PV over RT. Right? Here, people, Z is known as the compressibility factor. Now, this concept I have to tell you. What is compressibility factor? Why do we measure this? People think there is a spring like this. There is a spring. Okay? Right. People, compressibility factor at 1 means something like normal. That means you can compress also, you can take it out also, right? Something like that. When compressibility factor is greater than 1, when compressibility factor is greater than 1, එකට වඩා වැඩි නම් it is hard to compress. A spring which is compressed too much like this. Now it is hard to compress, right? That means the compressibility factor is greater than 1. If something is easy to compress, just like you're sitting on top of a big pile of cotton, something like that, you can sit on that, right? That means, people, something like this. Here, you can compress easily. It's like very easily compressible. So that means Z is less than 1. Ah. Now you get an idea. When you draw that graph with pressure, Z is equal to 1. That means normal. That means normal. When something goes below this, that means what? There are overall, attractive forces, right? In between gas particles, if there are attractive forces, you can compress easily. Isn't that going into your head? Like, logically, think, will you? Like, there is a gas sample. Okay? I put some ropes into this. Right? Somebody from below is pulling on the ropes. And I am also pushing on this. You're standing here, let's say. I'll take an example person. Yeah. You have Bushra Zainab. Yeah, you go. How is it? So Bushra is standing on this. Standing on that piston, right? If somebody from inside is pulling this, pulling it down, then tell me, people, whether it's easy to compress or not. Easy to compress or not? Easy or not? Easy or not? Easy, ne? You can compress this way more easily. If someone is pushing on this, someone is pushing on this, don't come, pushing on it, right? Pushing away. Repulsions, right? Overall repulsions. If there are overall repulsions, is it easy or not? Easy or hard? Easy or hard? Hard. Nice. That means, people, I say it is harder when Z is greater than 1. Right? It is harder when Z is greater than 1. That means top part it is hard, bottom part easy. People, now I drew a graph like this, right? That means for real gases, sometimes it is easy, sometimes it is hard. Yeah. Sometimes it is easy, sometimes it is hard. Why is that? Let's talk about that in a while, right? Sometimes real gases are easy to compress. Sometimes the real gases are hard to compress. Why is that? Right? You got this idea? There are overall attractions. If there are overall attractions, easy to compress. If there are overall repulsions, somebody is saying not to come down, that means hard to compress. Compressibility factor is how hard is this to press. Compressibility factor is how much Bushra should put energy into this to compress this. If she has to put a lot of energy, that means hard to compress, right? Amari, Tadagaran Amari, right? If she has to put lesser energy, that means easy to compress. If it is less than 1. If it is greater than 1, hard to compress. Now, this is a relative factor. Is it 1 means for ideal gas? We are measuring it relative to ideal gas. Something like that, right? Let's say in your class, there are 30 students. There are 30 students in your class, right? So all run a marathon, let's say marathon, right? One person at a time. One person at a time running a marathon. You select one person and tell people who run faster than him, I will name them as 1, 2. That means a grading system, right? There are 30 students. From those 30 students, I'll say, okay, there is one person who is running faster than him, I'll give as 1, 2, 3, 4, 5. Right? Who is running slower than him, I'll give -1, -2, -3, -4. ඔය වගේ. හරි? දැන් මෙතන මොකක්ද වෙනස තියෙන්නේ? That one person we tell his value is 1. His value is 1. 1. You go beyond that, you have 2, 3, 4, 5 harder to compress. You go backward, not minus values, but 0.9, 0.8, 0.6, 0.5 until 0. Right? Until 0. You can go behind. That's the concept. Right? That is the concept. Right. Now, what was our story? Bushra is standing on this. Somebody is pulling down. That means easy. Somebody is pushing it. That means it's hard. Huh. Why is it easy sometimes? Why is it hard? People now remember the squishy ball theory. What? අර මේක තිබ්බේ නිල් පාට බෝලයක් අද කරන්න අරු ඉඳගෙන ඔහොම එකක්. Now take this into your mind. Imagine you're holding that ball. Initially, you can squeeze it easily. It goes easily inside. But after some time, people, you can't squeeze it anymore. You can't squeeze it anymore more than that. What I will, right? That means people for squeezing a ball also or something like this. Firstly, easy, then it becomes harder. Harder and harder to compress. Did you get the idea? Did you get the idea? Right? Initially easier to compress, little bit you increase, increase, and it becomes harder to compress. Hari? I'll draw molecules like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now they are a little bit far apart. You can compress this, right? You can compress. There's enough space. You can compress. Hurry. Now easy. Easy. And becomes more and more easier. Why is that? More and more easier means why? People, they are attracting each other. Right? He's telling to him, come here. They are attracting each other. Why? They are real gases. They have intermolecular forces. They are attracting each other. They are attracting each other. People, one to one, they are attracting. Everyone has attractions. They're acting like a spring. They're pulling this. Not someone only pushes. Someone is pulling this, right? Pulling, 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 pulling. Come closer, come closer, come closer, come closer. Right? Let's say two water molecules, they attract each other, right? Little bit. Hydrogen forces and everything, hydrogen bonds, they attract each other. Get the idea? But people, something, if it is excessive, it is bad for our life. Using phone is good, but using phone excessively is bad, right? Using technology is good, right? So you can send messages to anyone, you can access any teachers, you can call anyone, you can have doubts, and you can simplify them, like solve them. Anything you can do, you can download PDFs, everything, right? But well, if you use it excessively, you download Instagram, Facebook, TikTok, and you waste time using that, play games, something, right? That is bad. Anything which is used excessively is bad. Anything, huh? I mean, literally anything, like relationships. If you do more than, I mean, not only girl boy relationships, everything, right? Friends relationships. If you go more with friends, go out, cut classes, that's bad, right? You have to stay with a limit. For everything, there's a limit, right? So if you pass the limit, what happens is it becomes bad, right? So you try to put it out of your life. Like, now gases are like this, they are trying to pull each other initially. Initially, අවුලක් නැහැ. කට්ටිය ඔක්කොම එනවා දැන්. හරිද? Now you are compressed. Now Bushra is happy. She has gone way more down now. හරිද? She has gone until here. Good job. Right? පට්ට. දැන් මොකද වෙලා තියෙන්නේ? Now gas molecules are like this, compressed. People, if your friend is in India and you're in Sri Lanka, you want to meet him or her, right? You want to meet him or her. But he comes to the, now you're in Kandy, he is in Colombo. Still you want to meet him. Now he is in, let's say, nah, he's in Matale and you're in Kandy, let's say, something like that. Still you want to meet him. Now he comes more closer. Dalanda exhibition is going these days. So he comes to Kandy, right? So now one person is near the clock tower, other person is near the Dalanda Maligaon, right? Now Colombo people might not know these things. It's like a little bit distance. And now your friend is coming in front of your face. Now very close. Very close now. He comes more closer. And you begin to panic now. Now you begin to panic. Now don't come any more closer. Why? It will be weird and awkward, right? It will be weird and awkward. Something like that. When they are more apart from each other, they have attractive forces telling to come closer. But anything more than that, they are going to repel. තව ටිකක් ළඟට ආවම දේශේ කෙක්වත් ළඟට එන්න එපා. right? Don't come anyone any more closer. They are pushing each other now. Because they also don't have space, people. They also need space. Muntat they don't. They they don't have space. Right? So what happens is they will give repulsions. Make a explain from electron clouds. Now molecules have electron clouds around it, right? Electrons. So what happens when another molecule comes so close? Electrons and electrons push each other, right? Electric fields, Norwich. Get the idea? Electrons and electrons push each other. See? Right? When two atoms come closer together, they are trying to repel each other, right? They are trying to repel each other. If they can, they will react. We don't put reactive gases in this. If they are not reacting, then they will never react, right? So they will come close and repel each other. The electron cloud will arrange such that it's going to repel each other. Did you get the idea? Ternal. People, talk. Who? Right? I want to give this concept like magic to you. So make sure you focus and listen. When you compress more than you need, that becomes harder to compress. Got the idea, right? Next. That is why this curve goes like this. Initially, there are overall attractive forces, and after some time, it becomes hard to compress, and then this thing increases, starts to increase. At some point, people somewhere around here, pressure is so high. Now, this is the pressure axis, and x-axis is pressure. You are increasing pressure, right? You are increasing pressure, increasing pressure, increasing pressure, increasing pressure. At one point, the gas turns into a liquid. But if the temperature is less than the critical temperature. You will learn in phase equilibrium. What is that thing? A critical temperature and those things you will learn in phase equilibrium. For now, just keep in your mind, you compress this gas until a certain value. At that point, people, the gas converts into a liquid. Why? Molecules are so close to each other, packed to each other, and then they convert into a liquid. You know this concept. Right? Under very high pressure, people, under very high pressure, water boiling point could increase to 500 degrees Celsius, 1000 degrees Celsius, maybe sometimes. Under atmospheric pressure, only it is 100. You know that, right? When you increase the pressure so much, the boiling point increases so much. When you reduce the pressure, on the other hand, the boiling point of water reduces. Sometimes it might boil in 25 degrees Celsius. Right? These things might be new for you, right? Right? 3 or 4 times I have said this in class. That concept you are learning in phase equilibrium, where we'll discuss these concepts. For now, just keep this in your mind. Compressibility factor of a real gas ends at the point where it converts to a liquid. Even when liquid, right? That's the critical point. That concept right? Now you understand what is compressibility factor. You understand what is compressibility factor. You understand how ideal gases show their part in the compressibility factor variation. And you know the, I mean, whether it's hard to compress or easier to compress, you know the difference, right? The one who is below is easier to compress, one who is above is hard to compress. That one also you know. Third one, you know the variation of real gases. Right? You know the variation of real gases. Initially, there are overall attractive forces. Therefore, yeah, you can easily compress. Finally, people, Bushra, now this girl finds it hard to push it any much further, right? It becomes hard to compress. Why? Overall repulsions. Two friends doesn't like to come more closer to each other, right? Right? It's weird, right? I don't know about yourself. Right? So at one point, people, fifth one, you learned this point is the critical point. This is the place where the gas converts to a liquid. Did you understand? Did you understand? Right. Good. Now, people, we are going to sketch a graph for different gases. We're going to sketch a graph for different gases. Look. compressibility factor variation. This is for real gas 1. Z equals 1. This is the pressure. This is the pressure. Right? Now, we will CH4 gas. CH4 gas. මෙහෙම යනවලු. Right? CH4 gas will go like this. Somebody said. Somebody said. May experimentally proved. Right? Experimentally proved things. We can draw the graph from experiments. Then we will carbon dioxide යනවා මෙහෙම. ටිකක් උඩින් යන්නේ මෙහෙම. Right? Somewhere here. Then මෙහෙ පැත්ත බලන්න එපා. People don't look at this side. They won't watch very closely how you draw this side. But they will look at this side. ඇයි කියලා මං කියන්නම්. I'll tell you why. Why does this differ and all I'll tell you. This is carbon monoxide. This is CH4. Right? I'll draw two more gases. Hydrogen and helium. Helium will not go below. At room temperature, right? මම මේ කියන්නේ room temperature. At room temperature, helium gas does not go below. හරි? Helium gas will not go below. යන්නේ මෙහෙම. හරි? Helium goes like that. Hydrogen gas goes like this. Why do these gases show different variations? Helium goes like this. CH4 carbon monoxide. Why these things? People 2024 A level first MCQ. As I remember, they asked which of the following compounds is expected to have the highest boiling point. Now clear up your mind, clear up your mind and listen to this concept. Just think about this thing. There are some compounds and they are asking which one is expected to have a higher boiling point. Carbon monoxide tibba. Fifth answer. CH4 tibba third answer. I can remember exactly which answers were there. There was methane. There was carbon monoxide. What will be your answer? Which of the following is expected to have higher boiling point? Expected. Their word is expected. Expected according to our A-level scope. According to our A-level scope, we know carbon monoxide has dipole forces. CH4 has only London forces. Therefore, people, they ask expected. So, expected thing is, according to our syllabus, carbon monoxide should have a what? Higher boiling point. Carbon monoxide should have a higher boiling point. But in real life, CH4 has a higher boiling point. Right? In real life, CH4 has a higher boiling point. Are expected kina word they gave priority to that. People, this is the first MCQ. Are plum pudding model, Ernest Rutherford, 3 types of radiation, this MCQ was there as the first statement. Gattagamam paper, what do you do? Carbon monoxide, people, normally, if someone doesn't know this thing, that CH4 has a higher boiling point, he would put carbon monoxide and go home. People who know more than they think, normally ranking people and those things, my friends, they put CH4. Right? I don't know why is that, but they are asking expected. So expected people, carbon monoxide. But in real life, it is not carbon monoxide, it is CH4. And why that concept I took here? I make a denne. Carbon monoxide, CH4. Carbon monoxide, CH4. I told you, right? They will ask questions outside syllabus. Very rarely they ask, right? Syllabus this is one example for that. Check that MCQ and this question. May board A question People, if you know this concept, මේක දන්නවනම්, right? ඒ කියන්නේ making පෙන්නන එකයි ඒ question එකේ අහන එකයි, if you can differentiate, that means you're probably more than 80 marks in chemistry. හරිද? ඒවා අල්ලගන්න බැයි නම්, if it's hard, then forget it people. ඒවා තියෙන්නේ for higher ranking people. නැත්තම් if you are suffering in 40s 50s 60s ඒ වගේ concepts ඔළුවට දාන්න යන්න එපා. That is why I say past papers කරද්දී do it with some guidance. අර guidance එකක් එක්ක කරන්න, otherwise what will happen is you will go and study everything, A plus points and everything you will study, and what happens is A plus points you know but basic points you don't know. එහෙමනේ වෙන්නේ, right? Okay. දැන් ඇයි අර ස්ටෝරි එක මෙතෙන්ට ගත්තේ? හරි. This one goes on with intermolecular attractions. දැන් මං ඉස්සෙල්ලා අඳිනවා Bushra. It's okay if I take you, right? Again, I'm going to take you. Right? I'm going to copy paste Bushra into here also. You're a girl, right? So, okay. Hari, I'm going to copy paste her. Here is short, ne? Kapala wage nikan dan okay. Right? Here you have CH4. Here you have carbon monoxide. In real life, I told you CH4 has a higher boiling point, ne? Higher boiling point කියන්නේ මොකද්ද? Larger attractive forces නේද? Right? Larger attractive forces. Got it? Larger attractive forces. CH4 has larger attractive forces. Hari. Larger attractive forces. That means his hydrogen bonds are strong, people. මෙයාගේ hydrogen, sorry, මෙයාගේ dipole තිබ්බට people, his London forces are stronger than that. That is why he has a larger boiling point. Larger boiling point means attractions larger. Attractions larger means he can go more down, right? Did you get that? Lacing යන්න බලන්නේ පල්ලෙහාට තව ටිකක්. Why? They are pulling more. End again. They are like calling for Bushra. Come closer, right? Did you get the idea? තේරෙනවද? Huh? Tell me, people, quickly. Elano. I want you to reply to me. Right? It is easily compressed than carbon monoxide. Right? Carbon monoxide has overall repulsions. Then what about helium and hydrogen? Then make a mehemai people now. Helium gattot ehema, don't think like helium is always on the top. Ehema nae. This is at room temperature. Ne? This is at room temperature. If we reduce the temperature, helium would go below sometimes, right? Helium would go like this. Sometimes helium would go like this. Sometimes like this. Sometimes like this. Why? When temperature increases, you know this variation, right? Right? So at room temperature, this one. So that is what you have there. How temperature අඩු කරොත් මේක පල්ලෙහාට යන්න පුළුවන්. He can go down. He can go below. At colder temperatures. But if you increase temperature, you know the compressibility factor variation will stretch out and go to the top. Right? Now this is at room temperature. All gases are at room temperature. Okay, තමයි resource book එකේ දීලා තියෙන්නේ, right? At room temperature. But if you increase temperature, decrease temperature, these things change. Because they are real gases. Temperature වෙනස් කරද්දී මේවා වෙනස් වෙන්නේ why? People, they are real gases. Real gases in තමයි changing, right? Okay. Nice. මට කියන්න ඕනේ very hard concepts ටික මං කියලා ඉවරයි people. Like very hard concepts I had in my mind, I told them and finished. Right? So now people, I have to explain this tute. Then tute tek ගන්න. Right? Tute tek ගන්න people. In the tute, thank you. Hari. Here Z is known as the compressibility factor. It shows whether the gas is deviated from real gas positively or negatively. It shows whether the gas is harder to compress or easier to compress. Hence, right there. Hence, right there. When pressure, sorry, when Z is greater than 1, when Z is greater than 1, right there, when Z is greater than 1, it's a space in hence, when Z is greater than 1, when Z is greater than 1, it is hard to compress, right? When Z is greater than 1, it is hard to compress. When Z is less than 1, when Z is less than 1, it is easier to compress. Anyone who wants to join the revision class, drop a message to this number. I'll send the number to the. Look at the Zoom chat. Are you? Right. මම මේ ඇඩ්වර්ටයිස් කරන්න මේ people අද meeting එක මම free දුන්නේ. This not for advertising purposes, but I didn't share this or anything. මේක ඕනේ කට්ටිය ඇවිල්ලා බලයි. Then නිකන් ඉන්න ගන්න, right? Because this concept is hard for students to understand. I know when I learned this in my class, I had no idea what he's talking about. හරි. මම ගෙදර ඇවිල්ලා මම තනියම මේක resource book එක බලලා different videos තියෙනවා YouTube එකේ මම YouTube එකේ බලලා තමයි first share එකේ කරේ ඕක. හරි. එතකොට second share එකේ මම gases වලට එහෙම මුකුත් class ගියේ නෑ. This thing I learned in my first share. So I had no idea what he's talking about even. මට තේරුන්නේ නෑ මොකක්ද කියලා. අර concept එක මොකක්ද කියලා තේරෙන්නේ. Once you learn it correctly, මේක හරියට ඉගෙන ගත්තොත් මේක මාට lazy, right? This gases is the shortest unit. මේක තමයි කොටම පාඩම unit මේ chemistry වල තියෙනවා, right? Easiest unit and smallest unit. PV equal nRT, Boyle's law, Charles law, some like very easy questions people. Dalton's law of partial pressure. ඒක ඉතින් එන්නේ මොනවද තියෙන්නේ people? Gases කියන්නේ what a lazy physical unit එකක්, right? If it comes for the essay question, it would be like God has blessed you people. Right? If it comes for the structured essay. Lazy, right? Right? So, yeah, gets back to the note. Now, people, yeah, the variation of Z with pressure for different gases can be plotted as shown below. Right. Now, draw this. Now, tomorrow our results would come out. Tomorrow, Natang, day after tomorrow. Now I am in a situation like whatever the results come, I'll go to anywhere I can. I'm sure like medicine would come, but I'm not sure where would it come. Because I messed up my physics, ne, chuttak. You know, chemistry 46, biology 42, chemistry 35. Chemistry physics 35. Chemistry 46, biology 42, physics 35. Essay also somewhere around these people. So for physics, I think 70 or something, right? I'm aiming for something like AAB or maybe AAA, not sure. This one, not sure, people. This one, most probably it would come, right? So wherever the faculty I get, I'll go. I won't write it again. I can't write it again. Literally, you can understand the pressure inside this, right? So I won't do it again. I will continue the classes and I will continue doing my degree. Yeah, after 20th only they said they will release. So yeah. Because second shy, I gave my maximum people. That is literally my maximum. I then the bad people. You have a capacity to know the capacity, right? That's the maximum capacity. I then amari. Like literally you can't give more than that. Mega, you think it's easy to go chemistry 46? Make a more lazy කියලා හිතන්නේ. You can't go here easily. If you check the chemistry paper 2024, this is like a miracle. Again, 45 plus කියන chemistry paper එකේ MCQ එක, it's like a miracle thing. For me, it's a miracle because the question was paper was so tough. People MCQ, essay was somewhat easy. MCQ was tough. Right? Make a, I don't know what happened, that's panicking, right? Don't panic in the LL paper. Panic when they pa. Now, physics in the paper class, I was in the top list 2 times. So, even though after doing that, may count again, I was panicked at that moment. There was a big interval for us, like 20 days, 19 days interval in between our, but we finished bio, we finished chemistry, and then we had a 20 days interval in middle. So what happens is that your study mindset and everything goes away. You have only physics left, right? So hemodynamic effect now everyone affected that. Everyone has low MCQ count for physics except for like superiority. So most of my friends like 30s, right? 30s are panicking. People are that is something which happens. Don't panic. Learn to write papers within a given amount of time. Time make it a hurried lian people. Otherwise, what's going to happen is you will run out of time. When you are running out of time, you have only done 30 MCQs and there are only 30 minutes left. Our questions and you have only 30 minutes left. Definitely, you will get at least more than 13 questions wrong in the next 20. Definitely, yeah, experience can. Right? Definitely you will get more than 13 because if you don't know how to manage your time, that means you will mess up in the physics paper. Physics paper is one of the hardest paper in the A-level science stream. මං කියන්නේ maths lazy කියලා මං එහෙම මුකුත් කියන්නේ. What I'm telling is physics is tricky. Physics is the most famous question which is question paper which is discussed in A-level panels and teachers and everything. The questions, right? Sometimes they are discussing these questions for years. It becomes like it's a different vibe, people. Physics is a different vibe. You when you understand this, when you do another shy, if you let's say you do a second shy, you go more into this physics. Actually deeply you move into physics. And you will understand what is physics. Understanding once you do another shy. Or else after your exams, if you like study physics when you're home, I know. After exams, so you won't go and study physics. Science students, right? So if you studied someday like that, you will understand how beautiful subject physics is, right? In vain, people, I was so sad, like even after scoring that much in the school exam and the paper class and everything, in the A-level paper, you go to the war and your sword breaks apart, right? So what to do? Thank God I wrote other 2 subjects so well, so I hope nothing's going to happen. Let's see, right? So what, like, literally just don't unbalance the subjects. Do all 3 subjects equally. Otherwise, what's going to happen is subject unbalance could make you lose your dream to medicine, right? Mage unbalance එක ලොකුවට නෑ people. If it was like AAC or AAS, ඒක නම් යන්න බෑ people. You can't go like that, right? So make sure your subject unbalance. If you have subject unbalance, please correct that. And also, people, if you have a subject unbalance, if your physics is so low and chemistry is high and bio is high, don't give your full time to physics. Then what will happen is may දෙක අඩු වෙනවා. This he might go up. He might go up to here, but both of these will reduce. Like bio, if you don't study for like 2 or 3 weeks, you will forget. Circulatory system, if you don't study for 2 weeks, you don't know what is the open circulatory system. අමතක වෙනවානේ. Obviously, right? That's humans. We humans forget things. ඉතින් එහෙම වෙනවා. So make sure you balance all the 3 subjects correctly. I have told this in the special meeting. It's there still in the YouTube. You can watch that. And then prepare a timetable and may have methodical approach. We'll take another special meeting in the after exams. Now, after my results, I will take another special meeting and discuss with you like what to do in the remaining phase. ඒ වගේ special meeting එකකුත් ගන්නවා, right? After the results. Okay. Now, people, there. Once you draw that, have you finished drawing, everyone? Everyone finished drawing? Hari, drawing, you're right. Next one. 2 types of gases can be identified. Hari, 2 types of gases can be identified. Okay. According to your knowledge, tell me 2 gases which belong to 2 different, 2 types of gases. Look at this and tell. If I told a Montessori student to come and sit here, and ask him what is the different one out of these things, he would say, okay, yeah, this one is different. This one is different from this one, right? You make a straight line, make a curved line, yeah, right? Even a Montessori student or grade 1 student, grade 2 student could say, what is the different one out of this? Isn't that the same thing which you have to do? There are two types of gases. One have overall repulsions with each other. Other one have overall attractions with each other. See? Initially overall attractions, then only repulsions. Right? I'm talking about initial phase. Initially also hydrogen and helium have overall repulsions. Why? They don't have hydrogen bonds, they have very small size, so there are more repulsions than attractions. Protons and protons are touching each other, right? So very pushing forces are there, repelling forces are there. So that means what? They have a straight line thing like this. They are deviating from ideal gas behavior in the positive direction like this. And these guys are deviating in the negative direction. At one point, people, they will move like this and they will pass this compressibility factor one line and all will go to the positive side. It's like this. They initially go here and then again go like this. Okay. Right. Good. Read that part. Gases showing positive deviation, hydrogen and helium. These gases have overall repulsions than attractive forces. Highlight that. Hence, even when starting to compress, it's hard to compress. Therefore, Z value goes high. Second one, gases showing negative deviation first and then positive deviation. Initially, when starting to compress, these gases are easy to compress because there are attractive forces initially, but because there are attractive forces initially. But anything that is more than needed is too much. Highlight that and paste it in your wall and put it as a status also if you can. This is applicable for life also. If anything is more than needed is too much. Anything that is more than needed is too much, obviously, right? Food is needed, but if you eat food too much, then you will get fat and you will die sometime with a heart attack or something, right? Obesity, and then you will eventually die. So upon compressing after a certain level, then the compressibility factor increases because now it's hard to compress. Now it's hard to compress. Then variation of Z with pressure for same gas can be plotted as shown below with temperature. Now people, we are going to select. Which gas do you like? Tell me. What? Which gas do you like? Which gas? Which gas do you like? I ideal gas. Ideal gas can be I think, right? There is no variation in it. Right? Okay. CH4. Huh? Many voted like CH4. Lot of people voted for CH4. And, ah. Again, ideal gases. So ideal gas is like this. Huh? This is 100 Kelvin. This is 200 Kelvin. This is 300 Kelvin, 400 Kelvin, 500 Kelvin, 600 Kelvin. Nicely. Supreme maybe. You have nice brains, people, but you don't use that to learn. That's the problem. This is pressure. This is the compressibility factor, right? Huh. Initially, CH4 would show something like this. After certain time, people, I mean, you increase the temperature. Let's say this one 200 Kelvin. And you increase the temperature like this. So that's, I'm going to say 250 Kelvin. And you go further like this. And you go further like this. And you go like this. And like this. You deviate more and more. away from the ideal gas behavior, right? The more you increase the temperature, if this is my hand, right? The more you increase the temperature, what happens? Right? How to show it correctly? Right? Right? So I'm increasing temperature. Increasing temperature means elbow comes up and the hand goes down like this. And then after that, got the idea? This is called temperatures. You increase temperature means elbow goes up, that hand goes down like this. Right? And then like this. Ternal, did you understand? Me? Cold, warming, increasing. Hari. 200 Kelvin, 200 Kelvin, 250 Kelvin, 300 Kelvin, 400 Kelvin, 500 Kelvin. Right? I'm going to mark a perfect temperature like this. Perfect temperature again, this one. This guy. Penal. This guy. Are? So let's say 200 Kelvin is this one. This one is 200 Kelvin, 250 Kelvin, and this one is 300 Kelvin, and this one is 400 Kelvin. This one 500, 600. 500 Kelvin, 600 Kelvin. These are not exact values. People may hurry my values name for explaining purposes I drew it. Right? So people, once you go like this, once you increase the yeah, wait, I'll explain, right? So when you increase the temperature, what happens is elbow goes up, hand goes down. At one point, people, this elbow part is there. That guy is touching this Z equal 1 line for the most amount of time. That temperature is called Boyle's temperature. The elbow is touching most of the time in the Z equal 1 line. මේ line එක කොච්චර වෙලා touch කරන් ඉන්නවද, right? That amount of time you call that the Boyle's temperature. කියන්නේ වැඩියෙන්ම ඒක touch කරන temperature එක. That is the Boyle's temperature. For nitrogen there's a Boyle's temperature, for hydrogen there's a Boyle's temperature, for helium there's a Boyle's temperature, for CH4 there's a Boyle's temperature, for water there's a Boyle's temperature, right? The maximum amount of time where the gas is going to stay on the Z equal 1 line for a largest range of pressures. You call that the Boyle's temperature. So how to make a real gas move closer to an ideal behavior? You increase the temperature, increase the temperature, increase the temperature until this line goes to this blue color one. That is the temperature. But also people look at the pressures. If the pressure is high, that means deviating from ideal behavior. If the pressure is low, then ideal gas behavior. But we're not exactly close. Exactly close, right? Not exactly close. That's the thing, right? Not exactly close. Now people, in the prep paper 4, as Bushra said, I have given like in this graph, if I tell you to put nitrogen, nitrogen right? People, you can't find it, or theoretically you can't derive it in the paper and find it. What you have to look at is intermolecular forces. Intermolecular forces, right? Intermolecular forces. If the boiling point is high, that means intermolecular forces are high. When intermolecular forces are high, the curve looks like this. If there are overall repulsions, nitrogen has somewhat repulsions, but people, it will go somewhere closer like this and move up. නැත්තම් මේක මෙහෙම ඇන්දත් I gave marks for you. If you have driven it like this also I have given marks for you because people are එක students ගේ concept එක, right? It's the concept which the student is using. If he or she has used the what you call attractive forces to draw this, then she is correct. That's the only way which you can get it, by attractive forces. When attractive forces are large, that means the compressibility factor will move like this. Again, attractive forces වැඩි කියන්නේ මෙහෙම යනවා පල්ලෙහාට. Now people ammonia and all, it will go like this and then melt at this point. If at room temperature, ammonia වගේ නම් මේ හරිය නවතිනවා, right? Carbon dioxide and all will move like this, right? So people, right? That one we have to think about the attractive forces and think about that. The make concept එක ඔලුවට දැම්මට පස්සේ you can get the graph of anything. හරි මේක concept එක ඔලුවට දාගන්න people, that's the thing I want, right? Right. I'm telling TB is equal to 400 Kelvin. What is TB? Boils temperature. Draw this. Draw this. Draw this in the page number 18 top part. Page number 18 top part. That one farmer we cannot derive it like that within our scope. ඒක එහෙම හරියටම ගන්න බෑ. ඒක now if you search Google and all, you will get nitrogen below. හරිද? Z එකේ 1 එකේ in some diagrams goes below, some diagrams goes up. ඒක අපිට හරියටම කියන්න බෑ people. Right? We can't exactly tell it like whether it will go down or go up. ඒක experimentally ගන්න එකක්. It's like experimentally taken. What they will give is මෙහෙම එකක් දෙන්න පුළුවන්. They might say nitrogen at this temperature, let's say 200 Kelvin, it will go like this. මෙහෙම එකක් යනවා. And they will say at 300 Kelvin, draw the expected curve. එතකොට you guys, මෙහෙම that you will get marks, or like this also you will get marks, like this also you will get marks. You are not a god, right? You can't exactly tell how it will vary. එහෙම කරන්න අපිට concept එකක් නැහැ. We only have this much amount of theory part in the resource book for compressibility factor. ඉතින් ඔක්කොම කරන්න බෑනේ people. Yeah, professors are good people. They don't like to fail you. They don't want to fail you. They want you to pass the exam. Right? They are even taking the S level down. Right? S level down, C level down. Right? They want you to pass you. They want to pass you people. අමාරු විදියටම හදන්නේ නැහැ paper එකක්. Right? If they make it so hard, then the S level will go further down to 25s. හරි? ඒක අවුලක් වෙන්නේ නැහැ ඉතින්, right? Paper එක කමාරු නා කියමු. Let's say a paper becomes hard. That means for everyone it is hard. So it's fair, I think, right? Z score is what's going to determine a person's university dream comes true or not. Z score, right? Z score is a relative thing. Z score is depending on how your friend also performs. ඔයාගේ යාළුවා perform කරලා තියෙන විදිහත් ඒකට affect වෙනවා, right? It's going to affect. Among 80,000 students, it's going to affect. Each student is going to affect the Z score. ඔයා විතරක් නෙමෙයි, ඔයාගේ ලකුණු විතරක් නෙමෙයි people. All the students in Sri Lanka will affect your Z score. That depends. ඒකේ ලොකු theory එකක් තියෙනවා පිටිපස්සේ අර මම පස්සේ කියන්න after today's theory part I'll tell you. Right? When you draw and finish this, tell me. So people, inform your friends like someone like this is teaching something, come and see that something. We like that something, but you also come and see that something. අනේ ඔකක් කියන්න ඕන, right? අර මොකක් හරි එකක් මේ යකා උගන්වනවා. Like it feels like I can understand, come and check වගේ කට්ටිය ඒවා කියන්න people. For your friends also you inform, because we need to like spread this thing like a virus. We need to spread our class like a virus. I want to do that. I will do classes for another 2 years maybe, and I would stop this because if I go medicine, I won't do classes and I won't ruin my medical faculty dream, because I am just dreaming to get a first class degree and like that. මට full ඒකටම කරනවා වැඩේ. මම දැනට because I like it people. මං කැමති නැත්තම් මේක කරන්නේ නැහැ, right? If I like it only, just because I like it only I teach, right? අර පට ආසයි මේක කරන්න, right? You guys understand the things, how much I'm doing for this, the මේක කොච්චර effort එකක් දෙනවද කියලා, you know, right? The paper class marking scheme හදන්න ඕනේ, ඔක්කොම මං කරන්නේ, right? Everything alone I'm doing, printing, couriering, everything, right? Everything කරන්න ඕනේ, right? එතකොට මේ ගොඩක් ලොකු effort එකක් දෙනවා. ඉතින් මේක ඔයා හිතනවාද like with a with medicine it would be possible? Now you might say an example to me now. That person, people, now he did A levels in 2017. එතකොට that sir did A levels in 2017 and he could have got the degree in 2023. It was 2 years late. He failed one exam and 2 years repeat, right? 2 exams repeat. So that is why he got the degree now. Now 1 week ago, he said he's a doctor. Like, so I congratulated him. So in the group, so very proud of him, right? That's a big thing for him, and yeah. So අර ඒක එහෙම එකපාරක් repeat වුණොත් people, you won't get a first class degree or second class degree. අර එහෙම වෙන්නේ නැහැ. ඒක you will notice that when you go to university one day, right? Even whatever, not only medicine, now physical science, biological science, everything first class degree තියෙනවා, honors degree ගන්න පුළුවන්, right? පට්ට ඉතින් අර first class degree එකක් ගත්ත කියන්නේ island first වගේ වුණා තමයි, right? It's like a very big thing. If MCQ between 35 to 40, like 36, 37, will A come? Yes, probably. If it is physics and all, might come, people. Depending on your part 2. Part 2 නැතුව කියන්න බෑනේ. If you are done well in part 2, then you will get. If not, you can't. Simple logic. හරි, finish writing නේ. Right. Now I'm going to read. අද පොඩ්ඩයි කරන්න තියෙන දේ reading, right? Stay with this. When temperatures increase, the mobility of particles increase. So it becomes hard to compress. Therefore, compressibility factor increases. Agree, right? When temperature increases, what happens is molecular motion increases. When molecular motion increases, what happens? You can think this in 2 ways, people. අර මේක මෙහෙම හිතන්න පුළුවන්. When temperature increases, intermolecular forces break. I told you. එහෙම හිතන්නත් පුළුවන්, like intermolecular forces break apart and therefore there are no more attractive forces. අර එහෙම හිතන්නත් පුළුවන්. Or else you can say like when temperature increases, they strike the, I mean this bar, it strikes fastly. වේගින් වදිනවා, there is more force exerted on the wall. අන්න එහෙම හිතන්නත් පුළුවන්, right? So 2 ways you can think about that, how it is going to affect the behavior of the compressibility factor when temperature changes. Right? So people, yeah. Hence, higher temperature and lower pressure helps come closer to ideal behavior. Right? Before that, there's a statement. Here, it's clear that when temperature increases, it reaches the Z equal 1 line. Hence, approaches ideal gas behavior. However, there should be low pressures. Highlight that one. Because even though you are at the boils temperature, people, if the pressure is high, that means it is not closer to ideal behavior. Right? Is not closer to ideal behavior. Right? Okay. Hence, higher temperature and lower pressures helps come closer to ideal behavior. Highlight that one also. High temperature and low pressure makes the real gas go closer to ideal behavior. Now, in the beginning of gases unit, turn to the first page. When we were small, once upon a time. Once upon a time, I told you in the first page, ideal gases versus real gases. To achieve ideal nature, we have to increase temperature and decrease pressure. We wrote a small theory part for that. Why? Temperature increases, molecular forces tend to break apart. When pressure is low, there are large spaces in between particles. Therefore, intermolecular forces are less. Now, when you learn these things, now you have a more better idea about this ideal gas behavior and real gas behavior. When you increase temperature and decrease pressure, the compressibility factor variation also goes towards ideal behavior. You can see here, right? Closer to ideal behavior. So that is what we are going to, but that's what we talked back in the time. Now only you have a clear idea of it. Okay. The temperature which real gas behaves most as an ideal gas is known as the Boyle's temperature. Right? So Boyle's temperature is the temperature at which the gas exists most at the Z equal 1 line. Then continue to write there. There's a space there, so continue to write. For the above gas sample, the Boyle's temperature is, the Boyle's temperature is 400 Kelvin, 400 Kelvin, 400 Kelvin. Boyle's temperature is 400 Kelvin. Full stop. Boyle's temperature is 400 Kelvin. Full stop. This is the temperature. This is the temperature. This is the temperature at which the gas sample is acting closer, in which the gas sample is acting closer to ideal gas behavior. To ideal gas behavior. Hari. Now, people, we are going to derive an equation. I'll tell that later. We have to complete the theory today, right? Right. Now, people, we can also understand the difference in real gas and ideal gas using molar volumes. Then when temperature increases more and more, it starts deviating again from ideal gas, right, in the graph. Yes. It increases more than the required value, people. It will deviate more from ideal gas behavior. තව යනවා රේට. එතකොට එහෙම there is optimum temperature. Boyle's temperature කියන optimum temperature. ගොඩාක් වැඩි වුණොත් people there are repulsions. Repulsions වැඩි වුණොත් people that is also not an ideal gas. When there are more repulsions, එහෙම bad, right? It should be a normal value, right? It should be a normal value. Right. Now, people, we can also understand the difference in real gas and ideal gas using molar volumes, right? Molar volumes. මේක මං question paper එක දුන්නා. I gave this in a question paper. මේ derive කරන හැටි තමයි today you are going to learn. Hari, today you are going to derive. So there's a space given in the tube. In that part, you are going to derive this theory. No, graph is Z versus pressure. Z versus pressure. And for different temperatures, we are going to plot the graph like this. Different temperatures. Got it? Plot different graph for different temperatures. Got the idea? Farmer. Get the idea? Go. What happened? Fainted. Talk. Farmer. No. You can't put T like that. Who told? Compressibility factor is like variation with pressure. Compressibility factor, we are going to change pressure and look at the compressibility factor. Then gas sample, there is a gas sample at 100 Kelvin. 100 Kelvin, you are going to change pressure and then plot the graph. Point it's like a physics practical, right? You are going to first keep this at 100 Kelvin and then you are going to increase the pressure until 1 atm and then you are going to plot a point. And then again pressure increase a little bit, then again plot a point. Again plot a point. Again plot a point. Point. And now you have a graph. So this is at 100 Kelvin. So you take the same gas sample and you make it 200 Kelvin now. Again you plot this graph. And now you get a point above that. Here. Huh? Get the idea? Get the idea? Temperature වෙනස් කර කර අපි we are going to plot the same graph අර වෙනම again same gas sample we are going to change the temperature and plot it again. That's what we are doing, right? So get the idea. Get the basic idea. Think like a scientist. That's what I'm going to tell. අර concept එක තේරුම් ගන්න බලන්න people. Don't memorize. Just put the concept in your head because you won't forget it after that. Right? You won't forget it after that. For sure you won't forget. If you forget it, that means you haven't put it more logically into your head. Right? Ah. Now we are going to derive something. Derive something important. Look at you. For ideal gas, I can write PV ideal equals nRT. If I say n is equal to 1, that means assuming 1 mole of gas, I can write PV ideal equals RT. Right? PV ideal equals RT. Then for real gases, I can write PV real equals PV real equals the Z value multiplied by nRT. Hurry. Assuming n equals 1, here also we assumed n equals 1, here also we assumed n equals 1. So PV real equals Z into n into, sorry, n, Z into RT. If we subject Z here, Z is equal to PV real divided by RT. Right? PV real divided by RT. Right? So here you can see RT is equal to PV ideal. So instead of RT, we can put PV ideal, right? Instead of RT here, we can put PV ideal. So Z equals PV real divided by PV ideal. Now people, you're going to get a different idea about compressibility factor. V real over V ideal. Hari, make a derived line now in your tute. Write this safely without doing any errors. Write this safely. Write this safely. What does this mean? Compressibility factor is the ratio in between volume of a real gas sample and a volume of the same gas, which is ideal, right? Plot this value at the same temperature. The temperatures should be same. Done, eh? Right. Now I'm going to leave this equation only and I'm going to draw some containers. I'm going to draw some containers here, right? This one is a container. Okay, I have to measure it and draw now, right? There is a container containing 4 points. 1, 2, 3, 4. Right? Initially, the piston is here. Then I'm drawing the same one 4 times. Hurry. You can see I'm compressing the same container 4 times. In 4 different levels. Ne? The same levels are here. See? This one also. The same container, people. The same container. The same 4 points are there. The same 4 points are there. The same 4 points are there, right? Now what you're going is, we are putting an ideal gas into this, right? This is an ideal gas. Ideal, 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 ideal. The same gas sample we are including into this one. Right? Make it the same ideal gas sample we are putting. And then we are compressing, right? So let's say this one is 4P, 4P pressure, right? 4P, name P pressure. P pressure. This one is 2P pressure. Increase the pressure. This one is 3P pressure. This one is 4P pressure. Right? You're going from this one to this one, this one to this one, this one to this one. Right? Okay. Next. This one is a real gas. Initially, as you can see, before I'm starting to compress, let's say pressure P, they come equal here, right? Initially equal level. This is a real gas. The same real gas, I am increasing the pressure up to 2P. Pressure එක 2P කියලා මම වෙනස් කරනවා පල්ලෙහාට, right? But people, the gas is a real gas, right? The gas is a real gas. Real gases have attractive forces initially. Make a pressure එක වැඩි කරද්දී, who is standing here? What is the name of the girl who is standing here, everyone? What is the name of the girl who is standing here? Who is her? දැන් කලින් කිව්වේ? I took her in few examples, right? Yes, correct. Good. Everyone told. Right? Bushra is standing here. So serious situation now. She's standing here. Now what happens is, she's going to compress this up to a pressure of 2P, right? Definitely 2P වලට යනවා. හරි. 2P වලට ගියාට people, tell me the volume, would it be lesser than this or greater than this? Below this or above this? Again, real gases, if you apply the same pressure, would it compress more or repel more? Top or below? Below. Very nice. But, you get the idea. If you get the idea, that is all I want. Right? That means it is below than this second point. Down. තව යන්න පුළුවන්. ඒ කියන්නේ people, the same situation, it is below than the line. It is below than the line. Right? Below than the line. The line is here, see? The line is here. The line is here. But it is below than the line. Right? Get the idea? Right. Then people, next one. එහා පැත්තේ. Now you are increasing the pressure up to 3p. Now the pressure is a little bit more high. Right? The pressure is a little bit more high. If I draw the compressibility factor variation like this, if I draw it here, this is ideal gas. This is ideal gas. This is ideal gas. Real gas will go like this and like this. Z is equal to what? V real over V ideal, right? V real over V ideal. Z is equal to V real over V ideal at the same temperature. Then what? And the same pressure. Pressure is same. So this one and this one you have to compare. The pressure should be same. This one and this one you are comparing. Same number of moles, same pressure, same temperature. You are comparing the volumes. People, මේ දෙන්නගේ equal නේ පටන් ගද්දි equal. මන් ටිකක් වැඩි කරනවා pressure එක, right? Now 2p pressure. Here also 2p pressure තමයි. 2p pressure, but the volume is less than expected. So volume of the real gas or ideal gas is less. Volume of real gas or ideal gas is less. Volume of the real gas or ideal gas is less. Real gas is less. හරිද? Real gas එක අඩුයි. මෙහෙද එන්නේ, right? You can see that. Ideal gas is more. So tell me, Z is V real or V ideal? Is it greater than 1 or less than 1? The product. Make a product එක less than 1 or greater than 1. The numerator is small, denominator is big, right? It is less than 1. So obviously you get the idea, right? Z is less than 1, it is somewhere here still. හරිද? මේක තේරෙනවද? You get this big thing, right? This is nothing. මුකුත් නෑ මේක, right? You guys are just worried about it. හරිද? Initially the value is small. Real gas, the volume is small, see? Although the same pressure applied, same temperature, same number of moles, same gas, same gas. The real volume is less. And then what happens is the graph is still here. කට්ටිය තේරෙනවද? Tell me. තේරෙනවද? People understand? Did you understand? Do you understand? Everyone. Everyone talk. I want you to drop your ideas here. Shyam, Cedric, new students are here. So please tell me, did you understand this concept? Nice. ශානක දසුන් ශානක දෙන්නේ. Right. Then, now we'll go to this situation. People, මෙතනදී body වෙනසක් වෙනවා people. 3p pressure වුණාට now overall repulsions and attractions are same here. Again, මෙතනදී same වෙනවානේ. I'll put this one as point A. This one point A. This one point B. This one point C. Point A, B, C. C is this one and D is this one. Hurry. This is A situation. This is B situation. This is C situation. That is D situation. Hurry. Right. Right. B situation, the volume is less, right? Real gas volume is less than ideal gas volume. So therefore, numerator is small, denominator is great. Therefore, what happens is the compressibility is less than 1. Here, now the pressure increases and now people, it becomes equal to that. Ara point again, E point again. A point again, 3P pressure. Now the real gas volume and ideal gas volumes are equal, right? That point. Ah. Now you increase the pressure further. 4P pressure. මෙන්න මෙතෙන්ට ඇවිල්ලානේ. 4P pressure. Now what do you expect? The what do you call this thing above or below? Above, below. Which one? Above or below? Everyone answer will you. I can check how much did you understand this thing. මට පොඩි measurement එකක් ගන්න බලන්න. How much did you understand this thing? Above or below? කියන්න බලන්න. Tell me. Hmm? Everyone talk. Go. Bushra, Rifdi, Aruni, Abdul Muif. Where are you? Sleeping there? Are they not talking, huh? Aisha. Aisha and all. Did you join the what do you call me paper this month? Aisha, you didn't write any papers, right? I guess you didn't write any papers. You didn't write any papers this month. Am I right? You didn't write prep paper 5. You didn't still write prep paper 6. Am I right? Did you write? No, right? Ah, very nice. Now, ලියන්න බැයි නම් people don't pay. අපරාධෙන් people don't waste your parents' money. ලියන්න නැත්තම් people don't pay. It's not. I told you every week. If you are not writing papers, if you are not confident enough, if you feel like you're a, I don't know, please don't pay. හරිද? ලියන්න නැත්තම් pay කරන්න එපා. It's like bad for me also. I feel bad. You pay and then you feel like you can't join anything. අර අවුල් ඉතින් මට. One student, physical student කෙනෙක් හිටියා. Yeah. මම නම I won't tell the name, but that person paid me 5,000, not coming to the online class, not writing papers. මොකටද වන්දන්න? I don't know. I don't feel it's like somebody's donating me money. Like පවුහින්න මම පවුද? Like do I look like a beggar or something? Do you gift money to me? Right? Tell me. Everyone. Do I look like someone who is borrowing money? Like that is why you pay me? No, right? එහෙම එකක් නෑනේ, right? Some students are paying and not writing any papers, not coming to any class. මොකුත් කරන්නේ නෑ. Yeah, it's like charity. හරිද? මම නිකන් පව් කියලා මගේ එක්ක something is wrong with me and I have a disease and you guys are paying me because of that. එහෙමනම් කමක් නෑ people. You guys will at least get the benefit of that. Right? Yeah. I will create in the website charity. In the website, I'll create charity part. Then you can pay to that one, and I'll donate to kidney hospitals and cancer hospitals, and I'll donate it to that. You can pay me like that. Right? එහෙම කරත් අවුලක් නැහැ. Instead of paying me using අර මේ class fee කරලා මේ papers ලියන්න නැහැ, online class දෙන්න නැහැ, මුකුත් නැහැ. Just only the payment. Receipt එක එවනවා. Sir, I paid. එච්චරයි. That is the only thing which they sent. ඊට පස්සේ මුකුත් නැහැ. Class එකකට එන්නේ නැහැ, recording ඉල්ලන්නේ නැහැ, මුකුත් කරන්නේ නැහැ. paper ලියන්නෙත් නැහැ. They are paying and they are going. හරි. එච්චරයි. Charity. හරි. Next time I will include in my website. අර එහා පැත්තේ තියෙනවා මේ අර section එකේ දානවා මම charity කියලා. So when you are writing papers, if you feel like you want to pay, then pay to that one. හරි. ඒකට pay කරන්න. ඒකලා I will use that to something else. ලිව්වේ නැත්තම් මම ඒක charity වලට use කරන්නම් for cancer hospitals and you know different hospitals are there now. Fundraiser, yeah, fundraiser. Don't be a joke to the public. Everyone I am telling. එහෙම joke එකක් වෙන්න යන්න එපා people. If you pay, then make use of it. මේ නිකන් class එක තියලා some students ආ මේකටත් ඇවිල්ලා මොකක් හරි කරගන්නවනේ. හරි ලියන්න බැයි නම් people don't write. හරි ලියන්න බැයි නම් ඇයි pay කරන්නේ? හරි මටත් අවුල්නේ ඒක. හරි මම මේක කරන්නේ it's like I am not doing a charity here නේ. එහෙම එකක් නෙවෙයි කරන්නේ. I am doing something and if you are gaining benefit then write it. හරි මේක paper එක ලියලා paper එක I am correcting, I am discussing the paper, right, and then I am giving you marks, I am putting it in the website. ඒ හැම එකක්ම කරලා people, you guys are not like 4 papers per week. One paper නෙමෙයි 4 papers per week we do. හරි යකෝ ගෙවලා එන්න නැත්තම් ගෙවන්න එපා බං අපරාධي සල්ලි, right? For 3000 how many eggs can you buy? 2000 hari revision vitarak kawa kiyamuko. You are in there in the revision class ne. Let's say you for remaining 2000 how many eggs can you buy? How like chicken 1 kilogram is 1000 rupees, right? So 2 kilograms of chicken you can buy. You can eat that for 2 days, right, at least. You can buy something 2000 වලට කොච්චර දේවල් තියනවද ගන්න, right? You can do something beneficial instead of just paying me and not doing anything. මම මේක කියන්නේ people, I don't have any anger with you or anything. I'm just telling you, I'm thinking about your parents and telling this. Because you tell them like you are doing this, that's why I pay. ඒකලා ඔය කට්ටිය මුකුත් කරන්නේ නැහැ. They expect you are working but you are not working. It is your problem, right? ඔය කට්ටිය වැරද්දක් ඒක. Fix it. Right? If you can't fix it then go. හරි එන්න එපා class එකට. මුකුත් කරන්න බැරි නම් pay කරන්න එපා people. හරි ආයේ next month එකේ if you have paid me something, if you are not doing anything, I'll refund you the money and give you you send me the dues also, I'll chase you away from the class. Papers ලියන්න බැයි නම් ගෙවන්න එපා people. මුකුත් ආයේ no excuses ගෙවන්න එපා next month එකේ. හරිද? ලියන්න බැයි නම් pay කරන්න එපා. එච්චරයි. I don't care whether you get whatever the result you want, pay කරන්න එපා ලියන්න නැත්තම්. That's all. Even for physical students I'm telling, right? If you don't come to the paper class consistently week by week, end epa people. That's the thing. Because I can't take responsibility of a student who is not following the things and just paying me. Charity වගේ. හරිද? විකාර නම් නටන්න එපා people. This is a big exam. Don't think like you're playing with this. Right? Parties and trips and මේ ඔක්කොම දැන් යනවා ඔක්කොම. හරි ස්ටේටස් පේනවනේ මට everyone. හරි ඔක්කොගෙම ඒවා මට පේනවා. ඉතින් මම Instagram එකෙත් මම යනවා ඒකෙත් දානවා මටත් පේනවා ඉතින් ඔක්කොම ටික, right? So I feel I don't tell anything. මම ඉතින් chat එකේ reply කරලා එහෙම mood කියන්නේ නැහැ, right? I let them enjoy their life ඉතින්. හරි enjoy කරන්නකෝ enjoy your life value. හරි ඔහොම යන්න තව ටිකක් යන්න. හරි ගිහිල්ලා until 3 months left you start to panic, then you have no chance. ආයෙ එන්න බෑ people. එතනින් එහාට ආයෙ හෙලවෙන්නවත් බෑ. After 3 months from now, that means you're done, literally done. If you are S pass, you can't get it to an A. Time out. You can't do that. Right? දැන් කරන දෙයක් දැන් කරන්න නැත්නම් මේකෙන් අයින් වෙලා do something else. Go and make a paddy field and do a farm or something. You can at least sell eggs. හරිද? බිත්තර හරි විකුණන්න පුළුවන් එහෙම ගිහිල්ලා. Just go out of these A levels if you can't do this. අපරාධන people සල්ලි ගෙවලා විකාරයන් නටන්න නම් එපා. Right? Do something useful to the country at least. 3P pressure. මෙතන මං කියන්නම් කොච්චර කට්ටිය papers ලියලා නැද්ද කියලා, right? Now, Shuhaila and all, she said she can't come to the paper class. That's why she didn't pay. Of course, that one you can do, right? That's a good student. Not wasting parents' money. So she paid for only the revision and then went like that. සමහර කට්ටිය නා නිකන් සල්ලි ගෙවලා නිකන් අර මම් පව් වගේ සල්ලි ගෙවනවා, right? නේ මන් දන්නේ, right? Okay people, right. Then we are going to increase the pressure up to 4P. Then make the same situation point C and then point D somewhere above. Now you increase the pressure up to 4p pressure, and now what happens? The volume. Everyone told above, right? Except one person, everyone told above. Hari. උඩ තියනවා කියන්නේ මොකද්ද? That means hard to compress. ඒ කියන්නේ එකම pressure එක දුන්නාම volume එක ලොකුවට පෙන්නනවා නම් people, that means what? This ratio, V real over V ideal, the numerator is greater than the denominator, right? The numerator is greater than the denominator, so Z becomes greater than 1. ඉතින් Z greater than 1 වුණාම මොකද වෙන්නේ? The graph will move to the top. This is Z equal 1, Z greater than 1 means what? Huh. එතකොට here. Understand this concept. Hari. Real gas. Hari. Initially, the pressures are equal, the volumes are equal, as I said you, right? I'm assuming the pressure is P, right? Assuming the pressure is P. And then you're increasing the pressure, and then suddenly you can see, when you compress it to this second point, the real gas compresses even more down. තව ටිකක් වැඩියෙන් පල්ලෙහාට යනවා. තව ටිකක් ගියාම මොකද වෙන්නේ people? The volume is less now. The numerator is less than the denominator, right? So Z is less than 1. Hari. Z is less than 1. එතනින් mark කරා. Then people, we go further down. මේ හරියට යනවා. මේ හරියට ගියාම අර point C එකේ ඉන්නේ. මේක C යා. හරිද? Point C. Right? You're in point C. When you're in point C, people, it becomes equal to this one again. See? That crossing point. A crossing point එකේදී මේක equal වෙනවා. And then this side, we further increase the pressure. තව ටිකක් වැඩි කරොත් මොකද වෙන්නේ people? Real gas volume එක වැඩි than the ideal gas. That means what people? We can compress this easily than this one. Ideal gas එක compress කරන්න පුළුවන්. එයා වැඩි වෙන්නෙත් නෑ අඩු වෙන්නෙත් නෑ. Compressibility factor is always 1 for an ideal gas. මේක ඕන්න you can do like this and like this. Nothing will happen. Same. හරිද? අර freely movable piston. අන්න ඒ වගේ right? මොකුත් වෙන්නේ නෑ. මෙහෙම කර කර ඉන්න තියෙන දවසම right? මේකේ බෑ people. This one initially easier to compress, then up to here, then hard to compress. Now again you can't go any further. Why? Repulsions. Now Bushra here, standing here, මෙතන ඉන්නවා, මෙතන ඉන්නවා, මෙතන ඉන්නවා, මෙතන ඉන්නවා. Not enough. She can't go any more down. අල්ලු කරන්න අමාරුයි. Now take the route. Next page you have a space given, page number 19, top part. Page number 19, top part, draw this thing. Make a අඳින්න බැරි නම් take a screenshot now and then draw it later. මමත් photo එකක් ගන්නම්. I'll also take a photo. So you guys can draw it after the class freely by marking the points 1, 2, 3, 4. Hari, my screenshot එක ගත්ත people මේ I'll upload the thing in the group. ඕක අඳින්න වෙලා යනවා නැත්තම් you guys are keeping rulers, drawing. හරිද? අද රෑ 12ටත් ඇහැරලා ඉන්න වෙනවා එහෙම වුණොත් right? Okay. Now I'm going to continue. Also make sure you draw this thing. මේකත් අඳින්න. මේ curve එක ඇඳලා මේ points ටික name කරලා මේ ටිකත් ඇඳලා හරියට අඳින්න මේ ටික right? With the points like this 1, 2, 3, 4. Situation D, situation C, situation B, situation A. මොකද මේක resource book එකේ නෑ people. මේ වගේ explain කරලා resource book එකේ නෑ. You don't have it in the resource book. ඒක කියුවා කියලා you will forget everything you know also. හරිද? You have to read the resource book with a mark above 70. අන්න ඒ වගේ level එකේ if you read the resource book you will get it. නැත්නම් ඒක තේරුම් ගන්න අමාරුයි. I told you නේ resource book is like a dictionary. If you know the word, if you have heard the word, then you can look at the meaning of it. Right? Right? Then only you can look at the meaning of it. If you don't know the word, then you don't know, හොයන්නවත් බෑ people, you don't know the word also. Dictionary එකක් වගේ තමයි resource book එක. Right. Next. Consider the following compressibility factor variation. Mark points A, B, C, and D. Let's analyze situation in each of the points. Hari, listen. Pressure P, is it this one? Hari. Now, people, we are going to draw a normal compressibility factor curve. And then we are going to mark points A, B, C, D. Draw this. Draw this and mark. Page number 19, bottom. Page number 19, bottom. This one here. You have you see this one. Egandin. Draw this there. Hari. Then people, there you have spaces to write there. Start writing there. Under point A, right at point A, under point A, right? The external pressure applied is 0. The external pressure applied is 0. The distance between particles are infinitely large. The distance between particles are infinitely large. Distance between particles are infinitely large. Full stop. Interactions will not form. Interactions will not form. Interactions will not form. Ideal nature is seen at point A. Ideal nature of real gases can be seen at point A. Ideal nature of real gases can be seen at point A. Then under point B, right? Under point B, right? The pressure increases. The pressure increases. The pressure increases. Molecules approach each other. Molecules start to approach each other. Molecules start to approach each other. Molecules start to approach each other. Attractive forces become larger. Attractive forces become larger. Attractive forces becomes larger. The gas becomes easy to compress. The gas becomes easy to compress. The gas becomes easy to compress. Compressibility factor decreases. The compressibility factor decreases. Compressibility factor decreases. Right. Then at point C, right there, at point C right there, at point C right there, point C, the pressure is increased such that the pressure is increased such that the attractions becomes equal to repulsions. The attractions become equal to repulsions. Attractions become equal to repulsions. Therefore, compressibility factor is 1. But it is not ideal gas behavior. ඒක වෙනස්. ඇයි? The attractions are equal to repulsions. අර ideal gas කියන්නේ there are no attractions or repulsions. ඒක වෙනස්. හරිද? Keep that in your mind. Then right under point D. Under point D, right? At this point, hurry, write D, will you? Write D, will you? Write D, leave C, write D. Under D, at this point, the real gas converts into a liquid. The real gas converts into a liquid. Real gas converts into a liquid. Only if the temperature is less than the critical temperature. Temperature is less than the critical temperature. Only if the temperature is less than the critical temperature, right? Hurry. Compressibility factor variation done. Under point C, one person missed the note. Under point C, I told as pressure is increased, the person who missed the point C, others keep your pen on the table. Hurry. As the pressures are increased, the attractions becomes equal to repulsions. Attractions becomes equal to repulsions. Therefore, compressibility factor is 1. Therefore, compressibility factor is 1. මම කලින් කියූප එක නෙමෙයි දැන් කියන්නේ චුට්ටක් වෙනස් කළා කියන්නේ because I think and tell me, right? Compressibility factor becomes equal to 1. Same concept, different words. Compressibility factor becomes equal to 1, right? Then, right? Compressibility factor becomes equal to 1. Hurry. That's it, people. Compressibility factor done. හරිද? අපි මේ now van der Waals equation එකයි gas diffusion effusion, this is just a 15-minute part. ඒක අපි next day in the organic together with organic conversion practice will do this part. හරිද? අර now physical students you are getting that in Friday, online students you are getting it on Wednesday, right? So by Wednesday we would have got our results also, right? Excited to see that. My performance. හරිද? Okay, then we will Van der Waals equation part. Let's do on Wednesday and finish it off. So gas diffusion and effusion, there's nothing there, just a knot. So that part will complete on Wednesday. So people, we technically have finished gases. Now we have finished gases. You can do all the MCQs in the tute. MCQs 60ක් තියෙනවා. 60ම discuss කරනවා. People, we have to discuss all the 60 MCQs. I didn't discuss even one MCQ from that. I wanted to finish this and discuss everything at once. Then I can put a video like gases මේ MCQ discussion එකක් දාන්න පුළුවන්, right? Those are past papers නේ. So past paper questions all I can discuss at once and finish it off, right? So start doing the MCQ workbook now and finish all the 60 MCQs within this month. Next month එකේ now this month you will get the QBT1. තාම print මේ courier කරේ නැහැ. On Monday I'm couriering. right? එතකොට මේ අද post office වහලා නම් මනම් ඒ scene ටිකක් යනවා එතන, right? So from Monday from Monday I'll send the news. So QBT1 you will get. 1 එක මේ month එකේ. Next month එකේ you will get QBT2. Most probably. right? Most probably you might get QBT2. QBT2 කියන්නේ මොකද්ද? Structure essay number 2. ඒක master කරන්න යන්නේ. හරි QBT1 කරලා එමුකෝ, you will feel the thing after that, right? From QBT1 you will feel the thing, feel the heat of the QBT1. Once you start to increase your marks, you will feel that, right? Then QBT2, QBT3, QBT4 හොම හැම question එකකම we are trying to give you. So make sure you are ready for that. If you have marks in the first structure essay also, you can do that tute. Tute take කරන්න බලවන් people, it's going to be a big boost for your marks still. හරිද? Okay. Then people, that's it. We have to end the class today. Compressibility factor we have done. It took some amount of time to explain this concept because this is something I told you, right? Make a පොඩ්ඩක් අර කමාරු concept එකක් කියලා දෙන්න. So that is why it took some amount of time. Van der Waals equation විතරයි තියෙන්නේ තව කරන්න. ඒක අපි Wednesday කරමු in the revision class. That won't be a free one. මේක නිකන් දැම්මේ ඉතින් අර කියලා දැම්මේ නෑ. නිකන් ඔහේ දැම්මේ before 20 minutes of starting I put it as an open link. I will put this as a recording in YouTube. මේ කියන්නේ වීඩියෝ එකක් විදිහට upload කරනවා. එතකොට everyone can watch that. yeah. So that's it people. You can leave the meeting now. We have finished today's class. Tomorrow's electrochemistry seminar I might not keep it. බලමු. Depends on the time, right? I might not keep it. I might keep it in the next week itself on Thursday. Let's see that. Okay. So I'll inform about that tomorrow in the group. Right? You can leave the meeting now. Have a nice night, ne? Good night. Okay, good night. Bushra, thank you for participating in our videos. Participating in the class, pushing the piston, right? Okay. You have I already like helped us in the beginning units, ne? Unit 2 also you helped us. So today also you helped us. Until the end, help us. Right? Leave the meeting now, right? Okay, thank you. You're welcome. Good night.